Are there any emergency issues? Anything at all that you guys see? If please let me know. But other than that, I can't find my coffee. I have no idea what I did with my coffee. And but the plan is your quiz will open up there this after. Well, I'm hoping there maybe around 11 o'clock, and maybe 10 o'clock, maybe right after class. It's ready to go. Uh, the quiz, you have a week to do it, and so it's basically an assignment. Yeah, and so you've got two assignments on the go as of today. You've got assignment one, which was is due there next week. Okay, and we'll go over that there. It's got the yellow highlights, and then I'll release quiz one there this afternoon or this morning. That's what I'm thinking anyway. And it's a good one, and it'll keep you busy. All right, and but very relevant. And then next week there is no class. There's only a test, and yeah, we're just on the go. And if you guys have any questions, please let me know. There has been some issues, and you guys have been, and the people that have emailed me, it's awesome. You guys are vigilant. You guys are hungry. You guys want this. So if there's any issues, keep on track of it, and please let me know. Okay, so other than that, if you guys got nothing, yes. Is there an emergency? I hope there's no emergencies there, Emma. So keep me posted if there is any. Other than that, we'll just keep on going. Okay. Let's have a look. We're just quickly gonna go over last week's PowerPoint. We're going to do it in a couple minutes, and if you guys there have any questions or whatever, shoot them up. But other than that, we'll just in 5-10 minutes, we're going to go over this right now. So let me share, and away we go. Perfect. So this is last week's lecture that we recorded, and I just want to give you guys a chance to ask any questions or not. I don't think it was that bad of a week, but we're going to find out. So we covered these three aspects of representation. And basically the whole course is taking mashed potatoes, taking this unorganized data, and organizing it for the purpose of serving humanity in whatever direction you want to take it. It's taking unorganized data and making sense of it. And, like for your assignment, and for your quiz and for your test, I'm going to give you unorganized data. You will organize it. And then to me, the most important part of all of this is answering the 2 or 3 questions that I put in the question about the data. And the only way to answer it is to organize it. And because that's what we are doing, that's what statistics is. It's solving, the whole purpose is solving real world problems, and with a health field objective. So, you know what I mean? Nothing too crazy here. We've got tables and charts. Okay. And here's your basic tally chart. Okay. So we've got the 4 lines and a stick, and you know what I mean? It's really not that bad. Okay, there's a tally chart. If you change a tally chart into numbers, right now you have this. So whenever you see a frequency distribution, all you've got is a column here with your ideas and the numbers that represent each idea. There's your frequency distribution. That's all it is. Okay? Generally, that's the first step in organizing data. So, perfect example. Here we've got some mashed potatoes. All right? You've got to organize it. And here we've got nursing, pharmacy, athletic, therapy. Excuse me. This is where I need my coffee. Okay, so you've got all this unorganized data here. Okay? And what we're doing here is you've got a field. Here's your idea, field of interest. tally, frequency, and you can see what we've done here. You guys have gone over this, okay? And there you go. Now it's organized in some fashion, and now you can answer some questions, which is the whole point. And what is the most common field of interest? Nursing. What is the least common field of interest? Other. There you go. Not too bad. There's lots of different questions you could ask. How many students were surveyed in total? Generally, a total is very good. And that's where we're going to get into there today, is the use of the total, because you'll need the total number of participants in the study, but we'll get there. Okay, and using the total, like here we've got our 40 constituents, 40 students, 40 participants here, and with the frequency and your frequency distribution, there is an extra column, and today we're going to get into extra columns, and we call this there the relative frequency. And you just take your number divided by your total, so 7 divided by 40, and you get a percentage. That's all we're talking about here. And a big thing that gives students trouble, and if you guys have trouble with this, I think it should have been covered there last term in 1030 math, but being able to flip percentage into decimal. 0.175, okay, that is a representation of 17.5%. If there's any issues with doing this, let me know. We'll set up a WebEx. 2 minutes, you guys will be flying on it, okay? So we got frequency and relative frequency. Please notice that you see your total here. Everything has to add up. We're gonna have different columns there today. If you guys have gone ahead and looked at this week's PowerPoint already, okay, you'll see there that there's extra columns. There's cumulative frequency and relative cumulative frequency. There's more columns, but they're cake. They're not bad at all. But please, while you're making these, like on the assignment and on the quiz there that I'll release there today, and then the test there next week, like I'll give you a table like this, right? And like field, I'll give you all these things, and you'll have to take the mashed potato data and organize it using the table. Very, very importante. All right? Make sure that your total. Sorry, that didn't. You get it. You got to make sure that your totals add up. Okay? And you're going to see there that even your percentages, they should add up to 100%. Okay? They have to. Because your total is 40 students, and that's 100% of all the data. So all of these guys should add up. Okay? And with rounding, you know what I mean, you're going to get 99.99 or 99.98. I like it. It's good. Okay? But this is where you're going. So please, when you're doing these, make sure that all of your numbers at the bottom, your totals add up. And we'll show you guys all these there today. And we went over the pie chart there. Okay, and all of these guys here are just fractional representations of the 100%. Okay, and a circle has 360 degrees. So if you want to figure out how much of an angle your pie chart will be, okay, we'll show you these right here. Here's another example. Okay, the following data represents monthly expenses for senior citizens living on a fixed income. I don't know. She's got to be downstairs. Bye, buddy. And you'll see here that we've organized the data here at your totals. You've broken it all down. And how do you figure out your percentage? Okay, you take your number divided by the total. There's your percentage. So $2,000 divided by 5,000 is 40%. Okay. And then you take your 40% and you multiply 360 degrees, because 360 degrees is your entire circle. We only want 40% of the circle. So again, this is where you'll need to change your percentage into a decimal. Okay? And if you have any issues with that, just email me. I'll solve that up. No problem at all. Okay? So you take 40%, which is 0.4 times 360 degrees, and you get your angle here. Now, for your quiz there, I'm going to get you... The big problem with this course is it's such a hands-on course. Like, you know what I mean? It's pen and paper. You know what I mean? Because there's Excel that does all this stuff for you. We're not going to go to a point where you're really going to need Excel. This is just kind of rudimentary, and pen and paper is the best thing for this. And like for your quiz there that I'll release there today, I'm going to get you to make a pie chart. And I've given you the mashed potatoes. You're going to organize it all. And at the bottom of page 1, I think that there's just basically an empty circle. And like you're going to do all this stuff, and you're going to figure out the angles. Am I going to measure the angles? No. Not, you know what I mean? If this section of the pie is 47%, I'm not taking a protractor and I'm going to measure that. No, for that section there, you would just write in 47%. It should be kind of representational, but I'm not looking for exact perfection. I'm not perfect myself. I'm looking for understanding and awareness. Okay? And so don't worry about these. You just keep on trucking. And you see here, is this really 144 degrees? I don't know. It probably looks like it, you know, but I'm not expecting exact degrees. I'm just expecting, you know, a sector here that everything should kind of look like it's all right. The numbers here definitely have to add up, but how it looks in the pie chart, I'm not too worried about. Even different colors is not a big deal, okay? And again, using your pie chart there, you answer questions. That's how she all goes. Bar graphs here, we're going to hit these there today. We're going to cover something called a histogram, and we need more information to do these kinds of things here. But you look at your bar chart here, and it all depends on whether things are, you know, discrete or continuous and these kinds of things. You have a look here. There's your grades, number of students. That's how these guys go. All right. And it's all just a matter of visually representing the data so that you can answer questions, right? We could use males and females in the same aspect. You just color code them right there. That's how these guys go. Okay. So if there's any issues with week 2 stuff, let me know. There's something here called the Pareto chart where the entire reason, it's just a bar graph. It's silly to have a different name for it. It's just a bar graph. And if there's no way to interrelate the categories, the only way to organize them is from highest to lowest. That's all this is. So the nice thing here about quizzes and tests and all these is that they're completely open book. So it's not like y'all have to memorize anything. You guys, when you guys are doing your quiz there this week, it's not really a quiz. It's more of an assignment. You guys can talk to each other. You guys can, you know what I mean, just have some fun with this and use this as a learning opportunity. You guys have time. Your test there next week. I'm assuming it'll start there next week at 8 o'clock. And the amount of time, I might provide some extra time. Sometimes, depending upon the course, I'll leave it open for an extra hour or 2 or even 3. Because you know what I mean? We have single moms, single dads. We have everyone's lives are completely up in the air. But I think things are getting better. Okay, so there's your, that's week 2. And I don't think it was that bad. All right. And, but week 3 here definitely builds on week 2. Okay. Now, where is... That's what I'm looking for. Here, let me take this off here. And... That's what I'm looking for. There we go. So, I've updated the assignment. I didn't change anything. I just kind of cleaned it up so that it was more visually nice. And I apologize. This all goes back to the whole thing where it would be so much easier to have these this course in class, because we're dealing with graphs and tables and charts and all these different things, and it just, Blackboard doesn't really have the capability to, it is what it is. So I apologize for, it's wait until the answer sheet here, but I've highlighted in yellow everything that there's a question, because it goes from these guys here, and we have the multiple choice here. Here we have choosing. So basically these are just true and false, right? Which one is it going to be, discrete or continuous? You're just going to circle which one, right? And I put these reminders in here all over the place that we're only looking at handing in the last 2 pages, just to try and simplify it for me by marking, because I'm going to have to mark 49 of these, and it's all good. And I apologize because the answer sheet, it's not particularly nice, but it's the best that I could do. So, and again here, identify the following variables as either quantitative or qualitative. All right, and you'll see here I've done my best to try and organize it. Okay, but again, this is kind of just a 50-50 question. Here's some unorganized data. Okay, you're going to organize it into a frequency table. That's all it is. Okay. We've got some other stuff here where I've given you a frequency distribution here, and I'm looking for, this is for the making a pie chart. So I'm looking at the what percentage does 7 hours represent, and what does corresponding angle, right? So we just have a look at week 2, which we just saw, and there you go, you're laughing. And you'll see everything should add up. All right. Some relative frequency questions, and here are some more questions there. There was a bit of an issue here. Even it looked good on my version, but then after I uploaded it, so I cleaned this up here. Okay, tea and coffee. All right, so it's nicely color coded. Okay, and you guys can answer the questions there. Another relative frequency. Here's a pie chart with some questions here. Okay, and then there was an issue here with coloring, and I've colored these here. So let me know what you think. There's a stem and leaf that's done. You're just going to interpret it. You're going to do a stem and leaf. So this is there's a lot of work to do here. Okay, today we're going to cover cumulative frequency and relative cumulative frequency. It's not bad. Not bad at all. Okay, and so there is 1 to 57. You're just going to fill in the answers there that are all these guys here. You're not going to fill in this. You're going to hand in this page and this page. Okay, so I can see that formatting, man. I just hate all this, man. Blackboard does things to these guys here that just. But anyway, it is what it is. So that's your assignment. Okay, that'll be due there next week. Okay, and bounce ideas off of each other. See what you guys come up with. And if something isn't making any sense, you guys just get a hold of me and we'll get it done. Okay. How we doing? Any questions? Nah, too early? All right. Let's go on to the last topic there before the test. Okay, so your test will be there next week. There is no class. All right, so it's just the test, and I'll give you guys some more details there. Today's Wednesday. The test is finalized. I'm just cleaning things up, so hopefully by Friday, you guys will know what's going on. The test will open at 8, and there should be a lot of time. Okay, I'm not really into giving a 3-hour block and that's it. I usually give a little bit more because people's lives are on their heads. So this is what we're going to cover there today. We're going to go back over stem and leaf, tally chart and frequency table, more review. We're going to deal with the histogram, which is just a bar chart. That's all it is with a fancy name, if histogram is actually fancy. We're going to deal with a cumulative frequency, which you'll need to perform an ogive. Interesting name. And then at the very end, we'll cover a bit of time series data and line graphs, that kind of thing. Okay? So just to go back. Where'd that go, man? Rats. Okay. Just a bit of review. Discrete data. Okay, this is obtained by counting. So if you're counting cookies in a jar or people or these kinds of things where you can't have halves. Okay, it's counting. Can you take on and these examples here are the best. And you'll see me. I'll refer to because we'll use these words all the time there during this class, and you'll see me refer to like counting the number of cookies all the time. So discrete data is by counting. Continuous data we do by measuring. And length, weight, time, temperature, where the counting scale or the measuring scale is continuous. And what do I mean by that? Is that 1.1, 1.2, 1.3, 1.4, we can measure, we can break things down into decimals. I can even break 1.11, 1.12, you can break it up. And using decimals, you need to measure these values, okay? Length, weight, time, temperature. It's a continuous scale held together by decimals. If you, the discrete data, it's counting. So it's going to be 1 and 2 and 3. There is no 2.5. There is no 3.5. These kinds of things, okay? So very, very important, okay? Quickly, stem and leaf plot. All right. I cover this a lot. There's about 10 slides here. I think I absolutely overkill it, but let's do it anyway. So a stem and leaf plot is one method of displaying data to show the spread of data or the dispersion. And that's part of the thing about taking mashed potato, unorganized data and organizing it. Is, like you'll see a bar chart or a graph or something like this, and it goes like this, and this is one of the things there we want to acknowledge. You take this data and organize it. How spread out is it? If all the data is around one point, well, then we've got something going on here. Like, why is the data all around one point? Why is all the data here? All right. And the flip side of the coin is the data will all be spread out. What does that mean? And we call this their dispersion or the spread. And you can even call it the range. And it's interesting, and we'll take this information with us there, and probably after reading week, that's when we'll get into all this kind of stuff here. But you just take these numbers here, and this is it's the most simple way of organizing data so that you can visually see it, is this stem and leaf. And so here you have these numbers here. Okay, 33, 35, 38, all the way up to 48. Well, here you go. There is your stem, and here are your leaves, right? So you take all, and you see you got your 30s, all your numbers in your 30. So here's your 33, 35, 38, 39. Take all your 40s, 42, 43, 47, 48. And you see what we have here now. All right. Now we've got this graph. You can see, and if you have a look here, we've just simply organized this data, and what does this data tell you? Well, you could look at it. Well, I've got 8 data points total. 33, 35, 38, 39, and I want you guys to be able to see this, that a 4 and a 3 here, this represents one data point, and it's actually 43. Okay, you could look at this. We have 8 data points. You could say that 50% of the data points are in the 30s, 50% are in the 40s. You could take this you could keep going with all this kind of stuff. Okay, so and another thing there with the stem and leaf is that it is organized from lowest to highest. Very important. Very, very important. Okay? Because now, what's your lowest number? 33. 3 and 3, 33. What's your highest number? Should be on the other side, in the opposite side, which is 48. All right? So this is what we're doing there. It's not that bad. It's just simple organization. And you have a look here. In the following set of data, which numbers would appear in the leaf column with the stem 5? So you just go through and you pick out all your numbers in the 50s. So I got a 55 here. I got a 51 here. Oh no, it's 500. That ain't 50. So that one's not going in. So you got 55, 51, 52, and 57. All right. So your stem would be 5. Your leaves would be 1, 2, 5, and 7. Not too bad. Any issues with that? Let me know. More overkill on the stem and leaf. You can see here. Again, it's just kind of the same thing. And the reason why I'm going over this is because I want this to be free marks. Okay? And I want you guys to get this because there is going to, like today's stuff there, where we're going to be in about half an hour or so. It's all right, but I want you guys to get this. I want you guys all to get A's. I have no problems in giving hundreds. No problem. Done it a couple times. Okay? So you see here interpreting a stem and leaf plot. And to me, this is the most important part of statistics. Nowadays there we have computer programs that do whatever you need to do. Where we're at, these we're not going to take it that far. The data there that we're going to be using is pretty usable, and but organizing the data is the first part. Interpreting the data to me is the most important. So here we've got a stem and leaf plot, okay, and you can see that this is a graph. If you can kind of visually with your mind turn it on its side. You know, you've got this graph here that goes up. The first one here, see how it goes up and then back down and then up. And so that's a graph in a sense. So what does all this mean? What is the total number of prescriptions filled over the course of the day? Well, you just got to see how many data points you have, okay, and add them all up. So 6 and 8 is 14. Here we have 10, 11, 13, and 14. And you see what we've done here is we've added them all up. And over the course of a certain day, there's 370 here. And that's what the question's asking. So please nail these. I'm putting them on the quiz and the test. I want them to be free marks. Okay, as I said, this is going to be the course that boosts your average. Okay. Again, overkill on the stem and leaf. All right, it's asking for the highest and the lowest. Well, I told you there before, and we'll tell you again, it's on the opposite ends there because you've organized these from lowest to highest. Okay. What else we got? Again, you guys can have a look at this. The kind of questions I could ask you, there's a million of them. Okay, so the first thing there, you're going to organize the data into stem and leaf, and then you're just going to answer questions there. The questions, they're real life, and so in some cases they will be wordy. Okay, but that's what statistics is. It's specific, it's exact, and sometimes the language can be. Well, on my tests, my quizzes, there's no interpretation. They should be pretty good. But I try and write these with your mindset, in tune. But that's an impossibility because I'm me and you're you. So if there's anything there that doesn't make sense, you just email me and we'll get her done. Okay? More on stem and leaf. Okay? Most important thing, sorting technique to arrange the data from lowest to highest. Okay? We've got here Just please make sure, like the number 38 is represented as a 3 and an 8. 156. Remember there was the example there with 500. I don't know where it was. It was up there a couple slides ago. Okay, but don't be fooled by that. If you have a number there, like in the hundreds there with 3 digits, okay, it would be 15 on this side as your stem and 6 as the leaf. Okay, and you can see here that these are unorganized. They haven't been put from lowest to highest. Okay, I'm just showing you guys examples of weird kind of oddities. Like if you have the number 08 or the number 8, how would you input that into a stem and leaf? Well, if it's only single digit, that means there's a 0 here. Okay, and then, so just even decimals, depending on how you want to put it, you can even put like 11.36, depending upon whatever scale you're going to use. Okay, so again, same thing here. Okay, all right, if you look at this, I want you guys to be able to see how many data points are we talking about for the 3s. Well, there are 2 data points. There's 36 and 38. Okay, how many data points do we have here? For the 4s, we have 41, 42, 47, 48. Let me know if any of that is irritating you. Okay. I've got these videos here. If the stem and leaf is still giving you trouble, you guys can watch these videos here and have a look. And if any of them there are bothering you, come and see me. All right. So ultimately, in a nutshell, stem and leaf plots provide a great visualization, okay, of the distribution. That's what we're looking for, right? Where is all the data? Because generally, when we get into what's called a normal distribution, that'll be like week 9, okay? When you're talking about population statistics, okay? And, we're talking about large populations. Taking a sample and projecting it onto a large population. We're talking, okay, 10, 20, 30 million people, right? And generally, your distribution of data, sorry, I'm trying to get to the camera here. Unbelievable, eh? And you'll see that's generally how a normal distribution works, where the majority of the data points are in the middle. Why is that? And even if you look at different distributions there, they will not be like this. Maybe they will look like this. Why are they like that? Why is all the data here? Why is all the data here? Today we're going to introduce a word called an outlier. Okay? What do they mean? Here's more about your tally chart. But I want you guys to see this. This is new stuff here. So have a look at this. All right. Here we've got these data points. Okay? And how many number 1s do we have? How many number 2s do we have? How many number 3s do we have? And we've organized this. And you have a look here. Okay, easy peasy. Here's a tally chart. Change these into numbers right here. Then now all of a sudden now you have a frequency distribution. All right, great. But have a look here. Look at these numbers here. Here I got... these are my ideas. These are my attributes of what I'm talking about here. And I got 1, 2, 3, 4, 5, 6, 7, 8. All right. So here I have 1 for 1. Here I have 1 for in 3 here. You see how it's not a very good representation? Like we have 1 here, 1 here, 1 here. It's kind of spread out. It's not really telling me anything. Okay, yeah, okay. I've got one thing here. I got another one here. It's just kind of spread out. So I got 1 here, 1 here, 1 here. What's that telling me? It's not really telling me anything. And what we're going to be doing now is we're going to be grouping. We're going to be making groups. And I apologize. I'm going to do a bit of reading here. But this is important stuff because this is all for the test there next week, and it's not so bad. So if the quantitative data is discrete, Now discrete is counting, and all the values are fairly close together. The categories in the tally chart can simply be individual data values. Okay, but it would not be appropriate to list individual data values as the categories in the tally chart. So what we're talking about here now is we're going to be making groups. This is not telling me any information that is relevant. Okay, so the data collected in discrete, oh geez, the data collected is discrete but quite spread out. And you see here it is spread out. And without any duplications, there would only be 1 or 2 marks in the category. And even, look, I don't have anything for 4 and I don't have anything for 2. I don't have anything for 7. So it's really, okay. The data collected is continuous as it becomes impossible to list all the possible values as categories. So you have a look here. Have a look at which one kind of makes more sense visually. And you'll see here that it's too spread out. We're missing gaps here. It's not really telling me a lot of information. But you know what we can do? We can group these. Okay, so using the same data, I've got a group here from 1 to 4. And I have 2 bananas in here. Here I have another group, exactly the same width. You know what I mean? 1 to 4. 1, 2, 3, 4. And then 5, 6, 7, 8. You see how they're exactly the same? The groups are the same width. And you see now, something visually happens here. So in these lower numbers here, I only have 2. But then something happens there, okay, 5 to 8. And now you can visually see that there's a difference. It's making more sense. And it's because we've made these groups. And you're going to see, I'm going to refer to LCL and UCL there all day. So as such, these situations require the use of intervals of value. And we call these classes. Okay. As the categories there for the tally chart. The lowest number on the interval is called your LCL, your lower class limit. The upper level on the interval is called the upper class limit. And the class size of the interval there, that's your class width. All right. So let's have a look here. Frequency and relative frequency distributions with class intervals. While there are no specific rules to determine what the idea of class width is, this is a very nice, easy peasy way of doing it. But there are steps here that are involved. Okay? So we're trying to figure out class width. And the class width should be convenient counting number. It should be easy to make. Now, how do we do this there? There should always be somewhere between 5 and 20 classes. So you've got your unorganized data here. Okay? And we want to organize it, okay, using groups. And I'll tell you whether I want group organization or not. Okay? So there's no issue of, you have your question, what is he trying, he's giving me this, he's asking for this, I'm going to go in this direction. Okay? There should always be between 5 and 20 classes, and the number of classes should follow this rule. Okay? And this is the 2 to the k rule. All right? Just a little formula you'll have to utilize, okay, in order to do a couple of questions there. Okay? So if you have data points, okay, a certain number of data points, okay, you choose a value of k with the number of classes. Now, how do we do this? How do I know how many classes I should have? Well, we'll show you. If there are 100 data points, how many classes should I make out of this? Well, Jesus, Murphy, man, stop doing that. So what we do is, now, how many classes? You're going to have to try and figure it out. You go 2 to the 4, find your number. 2 to the 5. Okay, which is 32. It's not enough. And you see what this rule is, whatever your number is here to try and figure out, it has to be greater than the number of data points. And I'm sorry if I'm not explaining this all right here, but if I have 100 data points, okay, I've got to input how many classes I would think. And here, experimentally, I just did 2 to the power 6. 2 to the power 6 is 64. Well, I've got 100 data points, okay? And that's not big enough. So then I go to 2 to the power 7. And you just do that on your calculator. You have a y to the x button. Okay, 2 y to the x 6 equals 64. Well, it's not enough. Then I go 2 to the power 7. That goes 128. That now has gone past my 100 data points. It's greater than 100. So this is what we want. All right. So I'm going to have 7 groups for this 100 points. All right. This will change if you had 50 points. If you had 50 data points, it would be 2 to the 5. It would be 2 to the 5 is 32, not big enough. So you need 2 to the 6, which is 64, which is higher than your number of data points. So that's what you would want there in that particular case. Any issues, come and see me. All data from the minimum value to the maximum value must fall within exactly one class. We'll show you these. Everything's got to be in a class. You can't have a data point that's in between classes. You can't have a data point that is in both classes. You know what I mean? You can't, a data point has to be in a certain class. Okay? And we're trying to minimize empty space here, empty classes. So you see here what we have, and probably you're thinking, what the heck is he on about? We'll show you all the steps here. And again, I'm going to ask you this on a quiz and a test, and you guys have the procedure here on how to do it. So I don't want you guys to worry too much about this. All right, you guys have it here. The questions in the for week 3, they go on and on. Please don't do all the questions that I've given you there for week 3. Do some of them though. All right, because there's too many there. All right. The triage nurse at the ER, okay, emergency room, records the weight in kg of 24 patients seen during her shift. Okay, so here we've got the weight in kilograms of 24 people who went into the ER. Construct a tally chart and a frequency distribution for the data. Okay, so first thing we got to do, you need to find the range. And what does the range mean? You subtract the highest number from the lowest number. That's all it is. You may want to reorganize this data from lowest to highest. When we get into mean median mode there, you'll have to do this. So it's just one of the things there that maybe you want to do it. Recommendations in a testing or quiz situation, if you're doing questions there for homework or whatever, you're going to need scrap paper. You're going to need something like this. It would be really difficult to try and do a question like this using your computer, touchscreen, these kinds of things. But if you guys have some way to write things down and just a scratch pad of some sort, okay? So you figure out your range and you find your highest number minus your lowest number, and there's your range, 71.6. Okay? And then now we got to determine the number of groups here, the number of classes. So to determine there the value for K for the number of classes, so we use our formula. So I have 24 points. Okay, so N is going to be 24. All right. So the number of data points here. So ensure that the value for K is somewhere between 5 and 20. So since there are 24 pieces of data, we need at least 5 classes. How did I figure that out? Well, you just arbitrarily punch in numbers into the K. So 2 to the 1 is 2. 2 to the 2 is 4. Remember, this number here has got to be greater than 24. 2 to the 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. And that number there is now greater than the number of data points. That's what we're looking for. That's how this formula works, okay? So we're going to have 5 classes for this group of data, okay? We're going to calculate the width of each class there by dividing the range by your value for k. And then you round up. So, what do we got here? We've got 71.6. That was our k value, all right, that we came up with, all right? Or, sorry, that was our range. 71.6, and you divide it by k. You get this number. Round it up to an even number. So whatever your number is here, 6.72. Hi, I think someone's microphone on, even though I love the sound of happy kids. We need more happy kids. I have 2 grouchy ones there downstairs. But anyway, that's how this one goes. So you take your range, divide it by your k value. You're going to get a number. Round it up. Don't round it down. Like you see here, 14.32. In normal mathematics, we would round it down to 14, right? It always goes up in this case. So even if it's 14.01, it's got to go up to 15. Okay? Now, what do we got here? So now we're starting to organize. Now we're starting to get somewhere. And we'll show you how this all works into a chart sooner than later here. But we're just kind of going through the steps here. So you remember your LCL. That's your lower class limit. All right. So you find your lowest data point, which we already said was 51.6, right? Because we used it there to find the range. All right. So you take your lowest data point, and we always like round numbers there, so we made that 50. Okay? All right? So, let's have a look here. Making our widths here, since the lowest class will start at 50, because that was based on the lowest one there, we just took it down to 50. All right? Now, the class width will be 15 here. Establishing the remaining LCLs by starting with the first LCL and adding the class width to it for as many classes as needed. So if the first LCL is 0 and the class width is 10, okay, then you will see here that's what you're making, your width. All right? So since the lowest class will start at 50, the class width is 15. All right? So you have a look here, because we've got 70 divided by 5. So here we go. And so your first class will therefore be 50. Your second class, again, will be 15, but it'll go from 65 to 80, 95, and 110. And you're probably thinking, what does all this mean here? I'll get to all this visually here, and we'll show you. Okay? There are differences here when you're talking about discrete and continuous, because discrete is, remember, is counting. Continuous there is measuring. So if the data is discrete, you set the upper class limit of each class to be one value below the lower class limit. And you'll see here, if we're counting cookies, have a look at this and make it make sense. If we're counting things, right, there's only 1 and 2 and 3 and 4. There's no in-betweens. So you'll have a look here. Look at this set of class systems. Here I have 0 to 9. And then I have from 10 to 19. And then I have from 20 to 29. Well, what if I have 9 cookies? Well, they'll be in here. What if I have 10? Then they'll be in here. There is no 9.5. So you'll see here that there is a gap in between these groups. And we use this style here for discrete. But if the data is continuous, where we're measuring, right? You've got decimals in there, so there is no gaps. All right? We use the word under. And you'll see here that group number 1 would be 0 to under 10. Group 2 would be 10 to under 20. Group 3 would be 20 to under 30. So these umbrellas there, like in this group here, 20 to under 30, that incorporates all numbers under 30, between 20 and under 30. So we go 29.999999999 would be in this group here because it's under 30. So different styles here. Take notice. Okay, for counting, we use this style to make groups. There's a gap in between. For continuous, there is no gap. We use the word under. Okay, let's have a look here. So basically, what we've done over the past 5 slides or so, we've taken this data, all right, and we've made these classes. All right, so the first LCL is 50 because the minimum data point is 51.6. All right, so here, and you see we've got decimals in here. This is not counting, okay? This measuring, so we use the word under. All right, so here we've got our classes 50 to under 65, 65 to under 80, 80 to under 95, 95 to under 110, 110 to under 125. Okay, so there are 5 classes because we figured this out there. The class width is 15. Okay, and the data is continuous. So the upper class limit will be the same as the lower class limit of the next class. So you see here, 50 to under 65, 65 to under 80. You see how this number here transforms over here, this number here transforms over there. You see how it works. Okay. So this right here, you will see a question like this on the quiz. Is it any more difficult? I think it's actually easier than this one. Okay. But try this out. There are practice questions available. Lots of them. So a little bit of advice here. When the quiz opens there later on this morning, I'll send an announcement out. Like, you have the whole week. You have until next week 8 a.m. to do your quiz. Please do not do your quiz today. Review the video, try the practice questions, and then do the quiz later on in the week. You have time. Don't forget about it, of course, but practice these questions first, okay? And then do your quiz. All right. What do we got here? We're going to start getting into a bit of graphical representation here. All right. For graphs of frequency distribution of quantitative data, unlike qualitative data, the horizontal axis usually represents a continuous number line. We'll show you all these. I'm just kind of saying these, but we'll show you these there. Okay. Recall there the class limit is a frequency distribution. Okay. The class limit in a frequency distribution of the upper and lower data values that fall into each class. For discrete data, there are apparent gaps. Remember, discrete is counting. Remember, there was a gap between, you had 0 to 9, and then you had 10 to 19. There was gaps in between, all right? That's for your discrete data. For continuous, no. Continuous is, use the word under. It includes every single number, okay? So as such, we need to establish class boundaries, okay? So for continuous measuring data, okay, the class boundaries are the same as the class limits. So you have a look here. You have class intervals 0 to under 10. Okay, this is for measuring data. 10 to under 20, 20 to under 30, 30 to under 40. But your class boundaries, in theory here, okay, they're 10. Okay, we've got, you look at your boundaries here. You've got 0. But you really don't have a boundary on the other. The boundary is 10, but remember, it's 0 to under 10. So it's 9.999999999. And you see, there really isn't a limit on these type of boundaries here for continuous. There's no upper limit. And then for the next one, you'll see 10 to under 20. Well, your class boundary there, basically you only have one. It's 10. Because then there is no really upper boundary. It goes to 19.99999, and those nines can go on forever. So that one goes on. So that's how these ones work here, okay? Just to make sure, here's your class interval. That's what they look like, 0 to under 10. But your class boundaries, really, you have a look. Where's your only boundary on 0 to under 10? Well, your only boundary is the 0. Because under 10 goes on to infinity, 9.99, right? So if that doesn't make any sense, have a read of the chapter and come and see me, all right? For discrete counting data, right? We're just counting cookies, okay? The class boundaries are halfway between the upper and lower. Have a look at this one. So your class interval, as we saw there before, 0 to 9 with a gap, 10 to 19 with a gap, 20 to 29 because there really is no half cookies. All right. And you'll see here the gap is 1. There's a gap between the 9 and the 10, a gap between the 19, 20. How much is the gap? Uno, 1. So halfway between 9 and 10 is 9.5. So in the case of discrete counting, okay, you're going to have these 0.5s in here. So the class boundaries are 0.5 on either side of the class limit. So you have a look here, 0 to 9. Well, your class boundaries here are going to be negative 0.5 to 9.5. And then for your next group, you'll see here, it'll be 9.5 to 19.5. All right. That's how these ones go. A little strange, all right, but that's how we do them there for discrete counting. And the whole reason why I'm showing you this is because we're getting to the histogram, okay, and the frequency polygon, because they utilize this information, okay. And the final important piece is the midpoint. Okay, the midpoint, the value that is exactly halfway between the upper and lower class boundaries. Okay, so for continuous data with class intervals 0 to under 10, 10 to under 20, 20 to under 30, remember this is measuring, the class midpoints would be 5, 15, 25, and 30. Midpoints in between the classes. 0 to 5, midpoint is 5. Continuous data measuring. For discrete data with class intervals 0 to 9, 10 to 11, or 10 to 19, 20 to 29, okay, the class midpoints would be 4.5, 14.5, 24, which are still half, all right, they're in between. So just be careful. Am I going to ask you all this on a test or a quiz? No, because I don't have time. You know, and that's just the whole point of testing is what I give you 30 kilograms of textbook and information, and what I'm going to ask you 30 kilograms of information and get it done in 2 hours? No. So have a look at the quiz and the assignment. They will provide you with an idea of where I'm going, okay? Because some of this stuff here we're not even going to touch, all right? But it's in the course. And what have we got here? So what we're doing here now, so once you've identified the class boundaries and the midpoints of the following distributions here, so if your class interval is 8 to 13, and if you have a look here, what kind of information is this? 8 to 13, 14 to 19. There's a gap in here. What kind of information has a gap? Okay, so you discrete, we're counting cookies. Your class boundaries are 0.5 on either side. Okay, so we have your class boundaries here, 7.5. Okay, 13.5. 19.5, And your midpoints for all of these guys here are just right in between 10.5. Okay. You'll need this information there to do this. Okay. And these aren't bad. These are just bar charts there that have a special name. Okay. And we call these there a histogram. And a histogram is a specific type of vertical bar chart. Okay. And you'll see here that there are no gaps in between. Okay. Because in this particular case here, look at what I got. 20 to under 30. 30 to under 40. 40 to under 50. 50 to under 60. There's no gaps in the data. It's continuous. Okay. On the left-hand side here, we have our class frequencies. These are from our frequency distribution. Okay. Just how many fell into each category, right? Okay, no gaps in here, and we have our class intervals are marked on the horizontal axis here. All right, honestly, try one of these once or twice there in the review questions, and you guys will be fine on this. Using the same information, okay, that we did there to make the histogram, okay, we just hit on the midpoints, and you see, you just put a dot. Literally a dot on the middle of each of these, and then you connect the dots, and you have what's called a frequency polygon. That's all it is. So if you have a histogram, then you also have a frequency polygon. Okay, and it's just a different way of representing the data. Okay, and how do we do the frequency polygon? You've got your midpoints. Okay, an additional class interval with a frequency of 0. You'll see here that the frequency polygon always hits the line. Okay, so it has a frequency of 0. So you better leave a space in here. Okay, because the frequency polygon has got to touch this baseline, and it's got to touch this baseline. All right, but what the hard part is doing all this stuff here. Okay, making your classes. But once you have your classes, and I'll show you, I have some more stuff there. The histogram and the frequency polygon aren't that bad at all. Okay, so you just follow this general rule right there. Outliers. I'm not really going to deal too much with outliers. I'm just kind of throwing this at you. I don't think you're really going to see any outliers at all for the first half of the course. But we'll hit those a lot there. We'll talk about them there at the end. Because, like, if you look at outliers can be significantly important. Like, the whole what an outlier is even look at this one right here. Here I have a distribution. Okay, where is, and here I'll blow it up. Okay. So you look at this distribution here of this data, and whatever we're talking about here, the number of cookies eaten, or what are we talking, a histogram for income distribution. Okay, whatever, fine. And you ask yourself, what's going on with this? What is happening? Can you explain it to me? Question number 1. Minimum, maximums, these kinds of things. Here we're talking about the number of households. Here we've got money on the bottom. But maybe a better question is, where is the majority of all the data? What are people making 100,000? Are people making 150,000? Where's the average? How much money are people making? Well, if you look here, go to your highest one. Generally, a majority of people are making between $50,000 and $75,000, right in here. And you could even say that, we could calculate the percentages, but, maybe half the population is making between 25,000 and what's this one here? 100,000? Yeah. So, so the majority of the data is here. So that's where we want to apply our focus when we're answering questions or trying to help socioeconomical, maybe economically depressed areas or neighborhoods, these kinds of things. Maybe people aren't getting vaccinated. Maybe this is in particular neighborhoods there, people aren't getting vaccinated enough or whatever. your majority of your data is here. That's where your focus is going to be. But let's say that you're a marketing specialist for Pepsi. And, here we're talking about the amount of soft drinks that people are drinking there in a year globally. Well, you see, you have what's going on over here. You have you have an outlier. And outliers can be absolutely distinct from the bulk of the data. So here's all of your data right here, but then you have a point over here. What's going on over here? Why do maybe I have 5 points over here that are, and statistically, they're really not that important, but monetarily, maybe these 5 points represents 5 million people. And maybe, like you look at the craft beer industry and all these craft industries that are coming up out of people's homes now. The whole idea of this, we have mega companies like, you know what I mean? You know what they are. But then micro companies there that are only filling a niche market. Well, maybe there's 5 million outliers. Okay, which statistically, maybe it's not a lot if you're talking about 7 billion people, but maybe some company is going after that 5 million people, which monetarily, if they buy your product 3 times a year, you know what I mean? You're talking, I don't know, $30 million. And if you're a small company, maybe that's where you're at. Maybe you're an outlier company. All right. So just the whole thing with an outlier is generally we tend to ignore them and sometimes even cut them off. Like if I'm looking at, I want to sell something to, I want to sell it to these people right here because these are most of the people. I'm not really looking for these ones here, but maybe you are. And you see here there's a tail off, and outliers are not a part of the general stream of the data. Sometimes we cut them off. Sometimes we don't. But we'll deal more with outliers there later on. So sometimes there are outliers in the data. That is very high or very low values. Could be on either side. All right. In these cases, it may be challenging to set appropriate class intervals and widths. You guys aren't going to be dealing. You guys, everything for your test and your quiz, everything is easy peasy. There's no tricks. I'm not here to trick you guys. I'm here for you guys to get it, understand, and get out. Then take this stuff and apply it, because you guys are going to have to have a little bit of statistics in here in order to get into your respective programs, whether it's paramedic, nursing, firefighting. They all deal with stats. Every single one of them. You'll be seeing them all the time. So your teacher will put up a graph like this, and you'll be able to instantaneously understand it. Okay? More about outliers there. I'm not too really worried about these. It's more about modifying and getting things going there for, we'll deal with outliers on a major scale after reading week. Okay. If you go into, I could show your quiz, but I won't right now. But so you've made these classes here for whatever reason, and you've got your frequency. Okay, so nothing new here. There is a new term though, and it's called cumulative frequency. Is it difficult? Nada. But all you're doing is you're taking the frequency, and you see here I've got 2 bananas in 30 to under 40. I've got 4 bananas in 40 to under 50. You see, these are my frequency. But a cumulative frequency here, you're adding them all up as you go. And there's a reason why we do this. It's kind of neat what happens here. So everything's in order. So first group is 2. But then what we do here is you go 2 plus 4. And so that from here to here, there are 6 participants or 6 bananas in here. And then for the next one here, you add 8 to it, which becomes 14. And then you add 11, which becomes 25. And then you add 8, 33, add 5, 38, add 2, 40. You notice there there's no total column. But please make sure that this number here matches this number here. Okay? They got to match, because the cumulative frequency has to equal the total. Okay? And you'll see here that we're going to do a little bit of a graph, okay, eventually. The next column is just your relative. And if you remember your relative frequency, that was just the percentages. So basically, what we're looking at is you're going to have like 5 columns. Okay, you've got your class interval, you've got your frequency, you've got your relative frequency in here, you can have your cumulative frequency, and you can have your relative. Relative, there we're talking about the percentage. Okay, and you'll notice there that for your relative cumulative frequency, it's the same thing. We're just adding as we go the percentages, and you'll notice there that that number there should equal 100%. Okay, and you'll take these numbers here, you'll take these numbers here, okay, and away we go. And you see what we've done here. This is called an ogive. And we use a cumulative frequency distribution. I'll say that again. We use a cumulative frequency distribution for ogives. And this is what an ogive is. Okay? And you see here, you've taken your numbers here. You've got 40, 50, 60, 70. These are all for the unders. And then we've got our cumulative frequencies. You plug and play. So here I've got 40, under 40 for 2, under 50, 6, under 60, there's 14 data points. And this is the accumulation. That's the word, the cumulative, is because you're kind of carrying everything as you go forward. So you're gathering more stones as you go, right? So we've got under 40 was 2. Under 50, what was that? 8? 6. Under 50 is 6. Under 60, I think it was 14. And for your ogive there, because you're gathering all the stones as you go, everything ends on 100%. And you see, the interesting thing about this kind of a graph is you can see where there's action. You can see what's going on as a percentage scale. So you've got, so here's 50%. What's going on here? Where is 50% as opposed, what's the upper 50% doing? These kinds of things. And so here you can deal with genres of people or groups of people, not just a single class. You can deal with class, you can deal with lower classes as opposed to higher classes. All right. I'm sorry, blow that back up. So and this is the last part here. Just the whole idea of a time series and line graph. These ones here are not bad at all. So here we have, we're measuring there the blood pressure there, the systolic and diastolic of a particular patient, okay, over the course of 10 days. Okay, 65 over 100, 160 over 94. You have a look here at what we've done. So you've got your systolic in blue, you got your diastolic in red, and day 1, day 2, day 3, day 4, all the way up. And here's your BP in millimeters of mercury, and you're just comparing, right? Please, if you're ever doing a graph, you've got to have a title and be specific. I'll be looking for it. And your sides of your graph have to be labeled with a good scale. All right? And yeah, that's that. You've got to have titles. You've got to have scales. You've got to have units there on the side. Tell me if we're measuring in centimeters or like right here, it says millimeters of mercury. Bingo. Now I know what we're talking about, right? You've got to have a proper scale with these kinds of things. Okay. It goes on and on. You know what I mean? You're just looking at different data points, and you can compare analysis. And again, it's talking about the legend and all these kinds of things here. A little bit of review questions here. Nothing too bad to work on. Okay. But that's everything there for your test. The questions, absolutely important. Please do not attempt the quiz today. Okay? Please do not. Please practice the week 3 stuff. Okay? Which are all right here. Week 3 questions. Okay? And again, please don't do them all. Like, the weather's so nice. Do some until you have a good grasp, and then get outside and get some vitamin D. All right? But you'll see here, construct a stem and leaf plot. For crying out loud, don't do all 4. Do 1, do 2, and then it becomes cake. All right? Here, they've given you a stem and leaf plot. Answer the questions. That's a good one to try. Okay? Here we're into tally charts, frequency distributions, all these kinds of things. Here are your classes. Okay, construct a histogram and a frequency polygon using this information here. Okay, and the answers are all there. Every single one of them. All right, and they're all there in awesome detail. Okay. And you'll see here that they're all here. And there's there it all is right there. Okay. And just be careful. You look at this. What kind of data is this? There's a gap, right? 140 to 148, and then there's a gap here to 149. What kind of data is this, right? So here you have, this is your histogram and your frequency polygon. All right. This is for counting data, right? Discrete. So have some fun with this as best as you can. And then when you feel confident there, do the quiz. But the quiz is there. It's not on, it'll be paper copy. Okay. Just because Blackboard is not really conducive, I'm going to try and get the test there next week completely on Blackboard. Okay. But this quiz here, you'll have to take a picture and upload it. Okay. And it's a horrible pain in the backside there to mark these for me from a e-learning point of view, but it's worth it because I want to see you guys pen and paper. It's the only way kind of to do these, and I can keep track. And never leave a question blank. I've seen show me everything that you can, because I'm huge about part marks. If you just give me an answer, 115 cupcakes, and the answer is 118 cupcakes, by the rules vested in me, I have to give you a 0. But if you show me how you got your 115 cupcakes as an answer, and I can see, and question's worth 4 marks, I'll give you 2.5 out of 4 every single time. Okay, so show me. And I'm giving you guys this opportunity. It's not a multiple choice test where, it's just the right answer or not. I'm giving you guys a chance there to show me what you guys, and practice these up, make mistakes, have some fun with these. Okay, because where you guys are going, statistics is going to be a part of the fabric there for the end of days. Okay, so that is that. That's all I got. So what do you guys got? Any questions? How are you guys doing? It's just trying to keep it all together, right? And but the most important thing there you guys can do is hit those review questions, and away we go. How are we doing? We okay? I'm going to stop recording now.